Today we will discuss regarding hormones and nucleic acids. Both of them will come under biomolecules only. First we will discuss regarding hormones. Hormones are the chemical messengers. They carry the information from one cell to the another cell. Thereby we can call them as cellular messengers. These hormones are secreted by ductless glands called endocrine glands. The specialized glands which are secreting the hormones are endocrine glands. Endocrine glands are secreting the hormones into the bloodstream. Secreting into the bloodstream, by the movement of blood, they are showing their action where they have to show their function. Where they have to perform their function, they are showing their action there itself. Here, these hormones are classified based on their chemical nature. Steroid hormones, non-steroid hormones. If steroid structure is present, then they are called steroid hormones. These steroids are two types again, sex hormones, corticosteroids. Sex hormones, corticosteroid hormones come under steroid hormones. These sex hormones in turn three types: androgens, estrogens, progesterone. Androgens are the male sex hormones. Estrogens, progesterones, both of them are the female sex hormones. Androgens produced by the testes, and that hormone is called testosterone. Because of this testosterone, secondary sexual characters of the male are enhanced. There is a change in voice after the age 13-14 in males. Body hair growth, mustache, beard, like secondary sexual characters are enhanced due to the production of these androgens, testosterone hormone. Next, estrogen, female sex hormone, principal female sex hormone, estradiol, produced by ovaries. This is responsible for the growth of long hair and it controls the menstrual cycle of a female. Thereby, secondary sexual characters are managed with this estradiol. Next, progesterone. As I said earlier, it is produced by the pregnant woman at the time of during the pregnancy. Progesterone is produced. This progesterone controls the uterus for the implantation of the fertilized egg. These three are the sex hormones consisting steroid structure. For that, these are the steroid hormones. Don't get confused with the androgens, male sex hormone, estrogens, female sex hormone. Progesterone is also the female sex hormone. In the pregnant woman only it releases. Next, corticosteroids. These are again two types. These are produced by the adrenal cortex, mineralocorticoids, glucocorticoids. Mineralocorticoids, this is the hormone produced by some tissues of the adrenal cortex. Adrenal cortex tissues are producing this mineralocorticoids. It balances salt water in the human body, and it is also balancing percentage of NaCl in the blood. Mineralocorticoids function get poor, the person may suffer from Addison's disease. Salt water balance, in summer the person used to get a lot of sweat, thereby there is a loss of sodium chloride. At that time, mineralocorticoids have to be activated by taking a plenty of water, and it also controls the percentage of sodium chloride in the blood. Of course, we won't have any blood, we won't take any blood, but if you taste, the blood is with some salty touch due to the presence of sodium chloride. That percentage is also controlled with this mineralocorticoids. Next, glucocorticoids. It is produced by the adrenal cortex only. This glucocorticoids controls the metabolic activities. One should know metabolism is nothing but the combination of catabolism and anabolism. Catabolism is nothing but destruction, anabolism is nothing but construction. We have to have the food and we have to digest that food, thereby the release of energy. Those processes come under together as metabolism. Metabolic activities, carbohydrate regulations can be maintained with these glucocorticoids. As these mineralocorticoids, glucocorticoids are produced from the adrenal cortex, these come under corticosteroids, and these are also having the steroid like structure. These come under again steroid hormones. This is regarding steroid hormones. If they ask only for the IPSET, if you write either of these two, you will get the marks. If it is for competitive exam, you have to be particular with the particular site where they are producing, how they are showing their function. Mineral ion balancing with the mineralocorticoid, glucose carbohydrate metabolism balancing with the glucocorticoids. The question may be like, what are the hormones that are produced by the adrenal cortex? Either mineralocorticoids or glucocorticoids. If it is both, if it is sex hormones, the answer will be the both. This is regarding steroid hormones. Up to now we covered steroid hormones. Non-steroid hormones are again two types: peptide hormones, amino acid derivative hormones. Of course, it seems to be the amino acid derivative, peptide, both may belongs to the protein category and they won't have any steroid structure. Further, we can call these are as non-steroid hormones. Here the best example for the peptide hormone is insulin. You might heard about this insulin. Insulin is the hormone which regulates glucose level in the blood. Insulin is secreted by pancreas. It releases insulin into the bloodstream, thereby the glucose level in the blood is maintained by this insulin. Actually, the glucose is to be present 65 to 110 mg per 1 ml of blood. As the production of insulin decreases, the person may suffer from diabetes. Diabetes is due to the lack of insulin or the decrease in production of insulin. Further, the diabetic patients used to take insulin in the form of either capsules or injections. The level of insulin if decreases, the person get diabetes. This is secreted by the pancreas. Now we will discuss regarding the structure of insulin. The structure of insulin was proposed by the scientist Sanger. He awarded Nobel Prize. Sanger awarded Nobel Prize for his structure. This insulin, it is having two polypeptide chains. One polypeptide chain is having 21 amino acid, another polypeptide chain is having 30 amino acid. Here disulfide bridges are present in between these polypeptide chains. These disulfide bridges we can observe in between cysteine amino acids. Wherever the cysteine amino acid is present, in between those cysteine amino acid, in between the two polypeptide chains, two disulfide bridges, within one polypeptide chain there is a disulfide bridge. Total 3 disulfide bridges we can observe among cysteine amino acid. This is regarding insulin. As it controls, as it regulates the glucose level in the blood, it is called hypoglycemic factor. Hypoglycemic factor regulates the glucose level. As the production of glucose enhances, the person's metabolic rate decreases and the person suffers from diabetes. This is regarding peptide hormones. Next, another one, amino acid derivative hormone. This produced by the gland thyroid and the hormone is thyroxine. Thyroid, it is a master gland as it controls most of the metabolic activities. As the person with low levels of thyroxine, hypothyroidism, high levels of thyroxine, hypothyroidism, we may observe. In nowadays, most of the persons are getting suffer with the hypothyroidism. thyroidism, the symptoms, more weight gain, there is a bulge at the goiter at the neck part. This can be controlled by taking iodine levels and thyroxine in the form of tablets. This is regarding amino acid derivative hormones. This is regarding the hormones. Hereby we will discuss some questions based on hormones. Which of the following will act as stimulator? Stimulator means encouragement for the performing of that reaction. Options are here: vitamins, proteins, hormones and enzymes. By seeing this question, of course, after listening the topic of hormones, one can respond hormones will be the answer, but here the options are somewhat tricky. Stimulator means which shows its activity by releasing or by secretion of that biomolecule only. Enzymes seems to be, but enzymes increases or facilitates the reaction to complete soon. So, answer is here hormones. Next the question. Androgens are options: male sex hormones, female sex hormones, steroids, both A and C. Androgens, as we discussed, these are the sex hormones. One used to remember androgens, estrogens are the sex hormones, but the student used to get confused whether it is male sex hormone or female sex hormone. But here, by seeing this question, one may get the one which is present at the first, male sex hormone. They can think and go for this option, but we have to check over the leftover options also. Steroids, both A and C. So, actually this androgens comes under steroids based on the chemical nature. So, the option it goes to both A and C. Instead of androgens, if the question is estrogens are, the answer will be the female sex hormones. Next question. Synthetic testosterone promotes pregnancy, controls menstrual cycle, another one muscle growth. One should be conscious while thinking about these kind of questions. Here the testosterone, it is related to the male sex hormone. It is produced by the testes, and these male sex hormones are also called androgens. Here the testosterone artificially, synthetic means prepared in the laboratory. It is not released in the human body. It is to be injected. That synthetic testosterone promotes muscle growth. For the sake of six packs in gyms also nowadays this synthetic testosterone is using, but it is not that much suggestible to have this synthetic testosterone. Next, another question. Which one of the following is the derivative of amino acid? So, one should be very familiar with the classification, unless we cannot answer this kind of questions. Here estrogen, mineralocorticoid and insulin. Last this thyroxine. If we recall the classification, we can answer for this. Estrogen, mineralocorticoids, both of them are the steroid hormones. In turn, estrogen is the sex hormone, mineralocorticosteroid is adrenal cortex tissues are secreting, that is not related to the derivative of amino acid. Insulin, it is the peptide hormone. Thyroxine is the derivative of amino acid. So, answer will be the thyroxine, which is secreted by the thyroid gland. Hormones that are anti-inflammatory. Options here: thyroxine, glucocorticoids, insulin, androgen. Here one should know anti-inflammatory. Inflammation is nothing but the secretion. Anti-inflammatory, as the excess of secretion is there, they are showing their against action. Anti-inflammatory can be regulating. As we discussed, carbohydrate metabolism is controlled by the glucocorticoids. So, glucocorticoids are the hormones that are anti-inflammatory. They are showing their action. Another question, hormone that is converting glucose to glycogen. So, hormone that is showing action on glucose to convert it as glycogen. Again the options we can take thyroxine, glucocorticoid, insulin and androgen. Same options for this. Glucose to glycogen means it is a process of metabolism that can be controlled by the insulin. Insulin is the one which controls the glucose levels in the blood. Next question. Insulin is secreted by, means what is the which body organ is secreting the insulin? Here thyroid, adrenal cortex, pancreas, uterus. So, pancreas. There are some tissues, islets of Langerhans of the pancreas are secreting this insulin, which is the peptide hormone as we discussed earlier. Next one, which of the following hormone controls menstrual cycle? Of course, by seeing this question, it is related to the female sex hormones. Options here, estradiol, progesterone, both A and B, testosterone. Here, as you know, testosterone related to the male sex hormone. So, there is a little bit of confusion comes, estradiol, progesterone, both A and B. These two belong to the female sex hormones, but here what I am asking the question, which controls the menstrual cycle before pregnancy only regarding this. So, it is not the both A and B. The answer is estradiol. These are the certain types of questions that we covered based on the topic hormones. Now, we will discuss regarding another aspect of the biomolecule. Okay. Now, we will discuss regarding another biomolecule, significant biomolecules, nucleic acids. These nucleic acids are the polymers. They carry the genetic information from one generation to the another generation. We can call that hereditary characters are transforming from one generation to the another generation through these nucleic acids. As I said, these are the polymers, means these are not having the simpler structures. These are containing nucleotides in the form of polynucleotide chains are present. These are nothing but nucleic acids are the polynucleotide chains. Basically, these nucleic acids are two types, DNA, RNA. DNA abbreviated deoxyribonucleic acid, RNA ribonucleic acid. Here the basic difference for the DNA and RNA, it is double stranded, it is single stranded. Here deoxyribose present as a sugar, here ribose is present as the sugar. It is one of the previous question. Ribose is nothing but the pentose sugar. Pentose sugar with furanose form. The structure is like furanose. First carbon with OH, H. Third carbon with OH is said to be ribose. Third carbon with OH group is said to be ribose, whereas in deoxyribose this OH group is absent. That is the major difference. It is the previous question. Ribose is the 5-membered sugar which is present in the form of furanose. Furanose is the ring structure. Oxygen is present in between the first and fourth carbon. If third carbon is possessing the hydroxy group, then that is said to be the ribose sugar. If third carbon without hydroxy group, then that is said to be the deoxyribose. Deoxyribose sugar is present in DNA. And one more difference with respect to nitrogen base. So one should know what are nitrogen bases. These in turn, two types are present, purines and pyrimidines. These two are bases only. Purines are in both DNA and RNA. Adenine, guanine are the purine bases that are present in both the DNA and RNA. In DNA, pyrimidine bases are cytosine and thymine, whereas thymine is absent. In place of thymine, uracil is present in the RNA. So, substitution for the thymine in RNA is uracil. These are the three major differences between DNA and RNA. It is single stranded, consisting ribose as a sugar, and it is having the nitrogen base uracil. In turn, these nucleic acids, as I said, carries the genetic information. At the same time, these are helpful for the synthesis of proteins. DNA helps for carrying genetic information from one generation to another generation, and it is also helping for the synthesis of proteins. RNA truly helps for the synthesis of proteins. So, these are carrying genetic information and useful for the synthesis of proteins. Nucleic acids along with the combination of proteins are said to be the nucleoproteins. Nucleoproteins are formed by the combination of nucleic acids and proteins. Regarding these nucleic acids, we should have one knowledge. DNA, as I said, it is not the simple molecule, it is the huge molecule. It is a polymer which contains monomers. The monomers of the DNA are nucleotides. Nucleotide is in turn consisting certain units. They are the combination of nucleoside plus phosphate group. Nucleoside plus phosphate group combination is said to be the nucleotide. Polynucleotide chain is nothing but our nucleic acids. In turn, nucleoside is also not the simpler one. It is also consisting two parts in it, nitrogen base followed with the sugar. Means the combination of nitrogen base and sugar is said to be the nucleoside. This nucleoside along with the phosphate is said to be the nucleotide. These nucleotides are arranged in a certain direction, means 5 prime to 3 prime in one strand of DNA, 3 prime to 5 prime in another strand of DNA. This is said to be anti-parallel. Anti-parallel means which are not interlinking, which are moving. One strand is moving from 5 prime to 3 prime, another strand is moving from 3 prime to 5 prime. Anti-parallel two strands are present in DNA. Then you may get one doubt, how these two strands are existing like a single structure. There exist an interactions between these two strands. They are hydrogen bonds. Hydrogen bonds are making them to held together. These hydrogen bonds are formed in between the nitrogen bases. They are purine of one strand to the pyrimidine of another strand. We have to remember adenine, guanine are the purines, cytosine, thymine are the pyrimidines. Now, in between the adenine and thymine, there are two hydrogen bonds. In between the guanine and cytosine, there is a formation of 3 hydrogen bond. By seeing this, you can't remember it as a double bond and triple bond. These are not the covalent bonds, these are the hydrogen bonds. Adenine is forming always with the thymine with 2 hydrogen bonds. Guanine is able to form 3 hydrogen bonds with the cytosine. Adenine never forms bond with cytosine, guanine never forms bond with the thymine. Of course, you can observe this kind of bonding truly again in RNA also, A to U, G to C. So, the number of purines have to be same with the pyrimidines to form these kinds of bonds, but in human beings, there is a purine to pyrimidine ratio, means purine to pyrimidine ratio 1.52, whereas in E. coli bacteria it's 0.92. It is also one of the previous bit. Purine to pyrimidine ratio in human beings 1.52 its value, means the percentage of purines are more compared to the pyrimidines. This is regarding the structural formation of the strand, and in between the nucleotides there is a phosphodiester bonds are also present to form like strands. This is regarding the information of DNA. How this DNA will exist, now we will discuss. This DNA is existing like double stranded helical structure, means the structure is like right handed, double stranded, means the two strands are turning towards right, and here the alpha form of this double stranded double helical structure is stable. Each turn is with a 3.4 nanometers, it is also the previous bit, and the diameter is 2 nanometers, each helical turn with 360 degrees. Here one more, this is called a minor groove and it is called major groove, where the crashes are formed, and these two strands are stabilized by hydrogen bonds in between purines and pyrimidines, and there are hydrophobic interactions are also present. One should remember these two, because sometimes while asking the question the options may be the both. Hydrophobic interactions in between the strands are holding together, and hydrogen bonds in between the purine and pyrimidine bases are also holding like double stranded helical structure. At melting point, these two strands get separate. The separation of these two strands is called melting. After cooling, these two strands exist like what I draw here. That process is called annealing. Don't get confused. Melting is the separation, annealing is the reformation into the structures. Now this DNA, as it is double stranded, it is involving in certain processes. Under replication, first generation DNA is producing second generation DNA. Parent generation, daughter generation. This is during transcription. Transcription is the stage, is the process of conversion of one of the strand of DNA into mRNA. mRNA, sometimes it may go back as the preparation of DNA in presence of certain enzyme like reverse transcriptase. That process is said to be reverse transcription. This mRNA is used for the synthesis of proteins by the process translation. So all these processes are interlinked. During the replication, one DNA gets formed as another DNA. During transcription, DNA is forming as mRNA. One of the strand is decoded as mRNA. mRNA can be reversed back as DNA by the process reverse transcription. This mRNA is used to synthesize the proteins during the process of translation. All these processes are interlinked. As the word mRNA came here, I would like to explain regarding the types of RNA. There are three types of RNA: mRNA, rRNA, tRNA. This is linear in shape. This is having the coiled shape. It is clover leaf in model. This RNA mostly it is linked with the ribosomes, and thereby it is utilized and useful for the synthesis of proteins. That part is very much important to us. Next, the most important aspect in this is DNA fingerprinting. Here, everyone, every human being, every living organism is consisting of DNA. The sequence of nucleotides are very much unique. One DNA may not interlink with the another DNA. So, there is a science, forensic science in that DNA fingerprinting is one of the best application to find out parental generation or paternity, to identify the dead bodies, to catch the thieves and robbers, and to rewrite the evolutionary studies. Regarding this, I will explain you. Paternity, to know the parental generation. Most of the time you might observe in televisions also, two people are quarreling about their child, then the court or law will suggest to go for the DNA test. To know the parental generation or paternity, DNA fingerprinting is more advanced technique. It will prove the 100% genuine thing. And during the accidents, during road accidents or train accidents or whatever may be the accident, the bodies may be collapsed and the dead bodies may not be the predicted. At that time, nearby parents of that or next generation of those people can be matched to know and identifying these dead bodies. At the time of robberies and at the time of crime things, to catch the criminals and robbers also, this DNA fingerprinting is very much helpful. And the extinct animals like dinosaur, the extinct, now what we are not having those kind of racial groups can be rewrite and studied under evolutionary studies. DNA fingerprinting is very much helpful. The sugar that is present in DNA, ribose, 2-deoxyribose, 3-deoxyribose, glucose. Here no doubt the sugar that is present in the DNA is the pentose sugar. The difference between the ribose and deoxyribose, absence of OH group at second carbon. This 2-deoxyribose is present in DNA. Next, another question. ATGC ratio in human being, that is 1 purine to pyrimidine ratio, 0.93, 1.52, 1.98. As I said, purine to pyrimidine ratio is 0.93 in E. coli, 1.52 in human being. So, the answer will be 1.52. Next, another question. Based on the number of hydrogen bonds, the number of hydrogen bonds between adenine thymine and guanine cytosine are 3, 2, 2, 2, 3, 3, 2, 3. So, if you remember the sequence, adenine to thymine like, guanine to cytosine like, you can repeat it. Adenine to thymine, 2 hydrogen bonds, guanine to cytosine, 3 hydrogen bonds. So, the answer will be 2, 3. These are the certain questions we will show regarding these nucleic acids. Now, we will discuss regarding another aspect of our senior inter chemistry, that is chemistry in everyday life. Its weightage for inter-public exams 2 plus 2, you will get 4 marks. One question definitely for the competitive exams. Very simple to score the mark from this chemistry in everyday life, because most of this related to our biological aspect, followed by the examples have to be remembered for each and everything. In this day-to-day activity, we used to take once in a week at least one person in your family tablets for different purposes. Regarding those medicine, we will discuss in this chapter. One should be very clear with the distinguishing between drugs and medicines. Drugs, most of the people, common people, they may have in their mind drugs are nothing but the addictive agents. Drugs are not truly addictive agents. If we take many times, these drugs will become as the addictive. Drugs will show its response immediately up to certain extent. The drug may not cure completely the disease. Drugs is to be taken continuously. For example, the diabetes person has to take insulin injections or tablets once in a day or twice in a day. If the person will take continuously for 1 year, if they stop taking for 2 days or for 1 week, they won't be very cure with the diabetes, because the drug, its action up to certain extent. After their action, it has to be taken repeatedly. Means it is not curing the disease. Drugs, they show their effect immediately up to certain extent for the relaxation. Whereas medicine is also the drug which is useful therapeutically. Means the stages of the disease can be used for diagnosis, treatment, curing. The drugs which are used to cure that disease, first initially it has to be diagnosis with the medicine. So medicine are also the drugs which are used for the diagnosis, prevention, treatment and curing. Complete curing of the disease can be done by using medicines. Under the part of this medicine, we will discuss there are certain medicines based on their mode of action. We will discuss analgesics, antipyretics, antimicrobials, antibiotics, antihistamines, antacids, disinfectants, tranquilizers and anti-fertility drugs. Regarding all this, we will discuss analgesics. These are the body pain relievers which reduces the pain, which controls the pain. Analgesics are again two types: narcotic, non-narcotic. Narcotic analgesics are the drugs or the painkillers which are used on severe condition, like during heart attacks, during post-operative conditions. Narcotic drugs have to be used. Non-narcotics are used to cure the mild pains like body pains, headache, stomachache. Here the thing what you have to remember, examples also for the inter-public exam sake, at least 2 examples for each one. Narcotic drugs, here heroin, codeine, cocaine are the examples. Non-narcotic drugs, aspirin, paracetamol are the drugs. Analgesics are the body pain relievers. Based on the severity of the pain, narcotic, non-narcotic can be used. Next, antipyretics. Anti, hereafter we will observe in most of the cases, anti is nothing but which is used and against to that. Antipyretics are the fever controllers. Body temperature reduces. By using these antipyretics, increase in temperature can be controlled by lowering the fever. Best examples for this: paracetamol, phenacetin can be used as antipyretics. Next, antimicrobials. So one should know what are microbes. Microbes are the organisms which are invisible to the naked eye, like bacteria, fungi, virus. Those can be controlled by using antimicrobials. There are certain secretions in our human body also are behaving as antimicrobials. The best antimicrobial is saliva, tears, which is having certain chemicals which are controlling certain body microbes which are able to cause the diseases. So antimicrobials. Next, antibiotics. We used to observe this word more rapidly along with the medicine as a combination. Antibiotics are the chemical substances which can be produced by killing bacteria like substances, which can be used in killing the microorganisms, preventing the growth of microorganisms. Thereby disease can be controlled by minimizing the entry of those organisms into the body also. There are certain antibiotics. First foremost antibiotic prepared by the Alexander Fleming is penicillin, by killing Penicillium notatum and Penicillium chrysogenum. Here we should remember, entry of microorganism is minimized by using antibiotic. After, if that is entered already, the growth of that, nothing but the multiplication of those microorganisms is controlled. Later on stage, the existing microorganisms are killed by the use of these antibiotics. One more thing that what we have to remember, these three steps cannot be completed by taking a 1 day or 2 day antibiotics. We are supposed to use as a course at least for 5 days or 7 days, unless the bacteria or virus which are causing the diseases may not be controlled, may not be the kill. Total disease may not be cured. They have to be taken in the form of a course. The best examples for this, penicillium, that is penicillin. Again, these antibiotics are two types, bacteriocidal, bacteriostatic, cidal static. Cidal is the one which is killing, completely kills the disease causing organism. Best example for that is also penicillin, and sulfur drugs are also present. Bacteriostatic, which are killing, and the bacteriostatic antibiotics are not taken in excess amount. If the severity of the disease, if it is less, that bacteriostatic antibiotics can be taken. Most of the cloxicillin, amoxicillin, ampicillin will come under this. Ampicillin, amoxicillin are some of the examples of bacteriostatic antibiotics. You have to remember the points. These antibiotics are controlling the entry of microorganisms, and multiplication of microorganisms is also controlled, and at last they kill the existing bacteria, virus which are responsible for the disease. Examples for this, penicillin, amoxicillin, ampicillin will come under this antibiotics. Next, antihistamines. As I said at first, these are acting against. Histamines are the inflammatory organisms, inflammatory glands which releases during the digestion. In stomach also antihistamines are releasing hydrochloric acid. Antihistamines controls the production of excess acid. It controls the production of excess acid. I am specifying the point because there is a little confusion with the antacid also. Antacid is the chemical or the drug which is used to remove the excess of acid which is produced in the stomach. Antihistamines controls the production of excess of acid. Here antacids, already excess acid which is produced can be minimized by taking antacid, and antihistamines are also used to control nasal health issues like nasal congestion, sinus problems, and nasal irritations can be cured with these antihistamines. Examples for these antacids containing basic magnesium hydroxide, aluminum hydroxide combination containing chemicals are the drugs that can be taken as antacid, whereas antihistamines are ranitidine, Zintac can be used as antihistamines. There is a little difference, you have to predict the difference. Next one, disinfectants and antiseptics. Antiseptics, again these are also used to kill the microorganisms which are causing the disease. These antiseptics can be used as ointments and lotions on living tissues. These cannot be taken inside as in the form of tablets and injections. These are strictly used on external purpose, in turn in living tissues only. The best example for the antiseptic is Dettol and iodine solution. Tincture of iodine. Tincture of iodine is nothing but alcohol and water consisting 2% of iodine. Alcohol water containing solution, if it is added with the 2% iodine, then that is said to be tincture of iodine. Dettol, it is the combination of Dettol combination, terpinol, chloroxylenol. It was the previous bit. Dettol is the combination of terpinol and chloroxylenol, and the soapy action for the Dettol is due to the presence of bithianol. It is also the previous bit. Bithianol, if it is added with any antiseptic, it is soapy to touch, and soapy action is due to that bithianol. This is regarding antiseptic. Next, disinfectants. Disinfectants are also used to kill the disease causing microorganisms on inanimate things like floor cleaning agents, drainage systems. Antiseptics, disinfectants, both of them are showing the same type of action, but antiseptics can be used on living tissues, disinfectants can be used on inanimate things. Here the percentage of the chemical actions to be added will be more in this disinfectant. Because of that reason it cannot be used as antiseptic. Formaldehyde, phenol solutions are the examples for the disinfectants. DDT, if you take, is also the example for this disinfectant. Gamaxin is also the example for the disinfectants. Up to now what I discussed, the students, most of you used to get confused with the antiseptic, disinfectant, inanimate things, disinfectants, on living tissues, antiseptic. Here also there is a little confusion. Excess acid can be controlled by antacid. Here the production of excess acid can be minimized by the antihistamines. For these all you have to remember the examples. Now another one, tranquilizers and anti-fertility drugs we have to discuss. Tranquilizers, these are used to control the central nervous system, thereby these are the drugs which are used for the psychos and neuro disordered persons. The examples for the tranquilizers, Valium, serotonin are the examples for tranquilizers. Next, anti-fertility drug. As the name is saying, fertility can be controlled by taking in the form of oral contraceptive pills. Now in India there is a lot of population. The population can be minimized and controlled by taking these type of medicine under the supervision and guidance of the doctors only. Anti-fertility drugs examples, mifepristone, novastrol are two examples for the anti-fertility drugs. Another part of this chemistry in everyday life which is linked with chemicals in food. Most of us know during the agriculture, during the crops, during the farming, most of the chemicals we are in touch with for the growth of those products. After assigning the products also we are in touch with most of the chemicals, knowingly or unknowingly. Because of the usage of these chemicals, what would happen means the appeal of the food may increase, means it looks good by the usage of chemicals, means coloring agents like. But coloring agents are not suggestible for asthma patients and children. Natural colors can be used by taking yellow color of turmeric powder, and for kesari, kunkuma puvu in Telugu it is called, that for sweets that can be used to enhance the appeal, and the nutritive values of the food can be enhanced by the chemicals. Nowadays everyone is to be conscious with the calories. So calories can be burned, calories can be supplemented by the alternative chemicals in substitution of the certain substances by taking certain chemicals. Now I would like to say the substitution are artificial sweetening agents, substitutes for the sugars. artificial sweetening agents and food preservatives. Here artificial sweetening agents. Natural sweetening agents, nothing but sugar, glucose like substances. Artificial sweetening agents may not increase the calorific value in the food. Here the first used artificial sweetening agent is saccharin, which is 100 times sweeter than sugar. Next aspartame, which is 200 times sweeter than sugar. Aspartame, which is 1000 times sweeter than sugar. Sucralose, which is 600 times sweeter than sugar. As I am saying these 100, 200, 1000, 600, it doesn't mean that you won't imagine how sweet these are. Instead of using 100 grams, if it can be used 1 gram. Instead of using 100 grams of sugar, saccharin can be used 1 gram. That is the thing that you have to observe. And here the aspartame, which is 100 times which is sweeter than 200 times which is sweeter than the sugar, is not stable, not resistant towards heat. Whereas aspartame, which is resistant to heat, during baking period also this aspartame can be used. Sucralose, here it is also very much resistant towards heat, which is used in biscuits, soft drinks like artificially, but sucralose sweetness may not be controlled. By taking the conscious of that, aspartame somewhat better compared to all these three artificial sweetening agents. By taking these artificial sweetening agents, the calorific values can be controlled and the sweetness is same as towards the sugar. So the diabetic patients can be used. These are the sweetening agents, but much intake may harm those persons. While using these, we have to be conscious. Next, food preservatives. Preservatives means the life of the food can be increased by adding food preservatives, especially the baked foods, bakery items, soft drinks. Those life can be enhanced by adding certain chemicals. The best example is sodium benzoate, it is one of the previous bit, and sulfur dioxide. These are the two best chemicals which are used as food preservatives. In our home, while preserving the pickles, we used to maintain the amount of salt in that. Thereby, salt is also the best preservative agent. Under this part, we can discuss regarding antioxidants, BHT, BHA, butylated hydroxytoluene, butylated hydroxyanisole. These are the two antioxidants. These two chemicals reacts with the oxygen amount that is present in the stored food. Thereby, if they are controlling the oxygen which are present in the food, bacteria, virus like microorganisms may not grow on the food. The food spoilage can be minimized and avoided by the use of antioxidants. This is regarding chemicals in food and related to day-to-day activities. Cleaning agents are soaps and detergents. Soaps are nothing but the saponification of esters of fatty acids we may get, and detergents, these are also the chemicals for the washing the clothes we use to detergents. There are certain types of soaps and detergents we can observe. Soaps, there are toilet soaps, shaving soaps. There are certain detergents also based on the availability of chemicals, cationic, anionic and neutral. If the positive charge more in the detergent, cationic detergents, if the negative charge is dominating over anionic detergents, both the ionic charges are sustained, we can call them as detergents. Here the detergents truly they are not having any soapy action in them, but these are also used as the cleaning agents. With this we discussed regarding different aspects of chemistry in everyday life.